Okay, the wind is moving horizontally at 12 meters per second over a level rectangular roof that measures 4.5 meters by 8 meters. All right, so here's this roof. And this is 4.5 meters, and this is 8 meters. Right, and the air is moving like this across the surface of the roof at 12 meters per second. So what is the pressure difference between the bottom and the top of the air? So let's assume that we're looking at a very short distance. So we're looking at from here to here, right? Use 1.29. Neglect the change in height and assume if you need to, the pressure underneath is 1.013 times 10 to the 5th pascals. All right, so let's set this up. Underneath the roof is situation 1, and above the roof is situation number 2, right? So we've got 1/2 rho V1 squared plus rho G Z1 plus pressure 1 is equal to 1/2 rho V2 squared plus rho GZ2 plus pressure 2, right? Okay, now the difference is that the air is moving on top of the roof. It's not moving here. It's still here. Here it's moving at 12 meters per second, right? So the pressure difference literally is just going to be this term right here, okay? So I'm going to say that V1 is 0. I'm going to say that these are the same height, right? So ultimately what we end up with is pressure 1 minus pressure 2 is equal to 1/2 rho V2 squared. The difference in pressure is just this, so we just plug it in, right? Let's plug in 1/2 times 1.29 times 12 squared. And this won't be a whopping difference in pressure, but it's a big roof. All right, so here we go. 0.5 times 1.29 times 12 squared is 92.88 pascals, right? So literally on a whole square meter, there's 92.88 newtons extra force, right? And that is, by the way, it's lower pressure here and higher pressure down here, right? So this is upward, right? This is an upward force on this thing, right? So what is the net upward force on the roof? Well, force is just pressure times area. So that's this 92.88. And this is, whoops, put a 2 in there. 92.88, right? And that's newtons per square meter, right, is really what it is, times the area of the roof in square meters. So 4.5 meters by 8 meters. This is 92.88, same number as this, right? Okay, so take that number, multiply by 4.5, multiply by 8, and I get that that force is equal to 3343.68 newtons, which if you want to figure that out in pounds, divide by 4.45. That's 751 pounds. So I've noticed this, right? When the wind blows, it's just blowing over the roof of your house, but you hear your house creak and groan, right? And that's because, well, 751 pounds of force is a lot of force, right? It's like a cow walking on your roof or something like that. Or lifting up on your roof, I don't know. If you look at when they construct roofs and things like that, they actually put little metal straps on them so that they can withstand these forces, which can be quite a bit. Obviously, if it's a hurricane, you know, your roof might come off.